In this lesson, we will be looking at a hypothesis test of a single population mean. Later in this course, we will look at hypothesis tests where we compare two means, but for this lesson, we're just going to focus on one mean. There are two possible cases. Case one is when the population standard deviation of sigma is known. And if we know the value of sigma, then the test statistic formula is that z, which represents our test statistic, is equal to x bar minus mu, so that's the sample mean minus the population mean, divided by sigma divided by the square root of n. In this case, we will be using the standard normal distribution table. When we know the population standard deviation, we use the standard normal table, the table with the z values, to find our critical value or our critical values. The second case is if sigma is unknown. If we do not know the population standard deviation. Keep in mind that if sigma is unknown, then S, which is the sample standard deviation, not the population, but the sample standard deviation, then that is known. In that case, the test statistic formula is that T is equal to x bar minus mu divided by S divided by the square root of n. So these two formulas are almost identical. The only difference is that the first case has sigma in it and the second case has S in it. So the difference between these two cases all depends on whether or not you know the population standard deviation of sigma. In case 2, if we do not know sigma, we will use the t distribution table. That's why the test statistic formula in case 2 has t is equal to as opposed to z is equal to. So when we do not know sigma and we only know the sample standard deviation of S, we will use the t distribution table. To find the critical value, we also need to know the degrees of freedom, and the degrees of freedom is equal to the sample size minus 1. That is n minus 1. It is possible that your degrees of freedom does not show up on the t distribution table, and in that case we will need to use the calculator to find our critical value, and we will see an example of that later in this lesson.